In this video, I'm just going to give you a brief explanation of these things called differentials that we use in substitution. Now, if this doesn't make sense or anything like that, it's really not the end of the world. You can still totally get an A or pass this class. You don't really need to know this, but it gives you good background. All right, so I'll be brief, or I'll try and be as brief as a teacher can be. All right, so the situation here is we have this function f of x, right? We have this function f of x here. And it is a continuous function, meaning you can draw it without picking up your pencil. And in our situation here, we're going from x equals a to x equals b. All right, so dx is defined as the change in x. And the change in x is this distance between, is this distance right here. That's the change in x. All right, now the change in y, this is going to be f of b minus f of a. And this f of b minus f of a, let's see here. See, this a goes up to f of a, and b goes up to f of b. So f of b minus f of a, that's this distance, otherwise known as that distance right there. Now dy is defined as this whole thing here, f prime of x dx. And that's this distance here. So you can see here that the change in y and dy are not very close. Here, change in y, right? Remember, change in y was this little piece here. This is not even close to dy. But the issue here is that my change in x is huge. My change in x there is rather large. So now think about what happens now. I'm going to draw in this green piece here, right? This is the error. This is the error. This is how far off dy is from the change in y. Now think about what happens now. Let me erase some of this extra noise here. Now think about what happens when we pull b back and make b really close to a. What happens to this little green thing, right? As we pull b back, right, let's say that, let's say we put b here, right? Then my change in y is that, and my error, how far off dy is, how far off dy, my differential for y, how far dy is off from dx gets smaller, right? So, and now think about moving that back even more. If you put b here, right, then here's my f of b minus f of a, and my error, how far off dy is from that, is that. And so it gets smaller. So if a and b are really close, if the change in x is small, then dy is approximately, so if this guy is small, how small? Very small, then what happens, then dy is approximately the change in y. And so that's how these things are defined.